Hi friends, in this session of normal distribution we study about how to transform x scale into corresponding z scale. So we take one problem relating to this transformation. The question is that the mean weight of 500 male students in a certain college is 151 pound and the standard deviation is 15 pound. Assuming the weights are normally distributed, find how many students weigh between 120 to 155 pound or more than 185 pound. So we see how we will solve this sort of example. So you see here I have written one formula of z scale transform in z scale. We have to use this formula for transformation x scale into z scale, where z is equal to x minus x bar over sigma. So now look at here, in this figure you see one normal distribution curve is here, and this is our x-axis or the x scale, and this is our y-axis we have, and this red line I have drawn here for z scale. Corresponding z scale we will get here. You see I have pointed some points here. You look at here at these places. These are the points of inflection or the point of change here I have given. So at this middle point I draw one vertical line and meet to the top of this curve. So first I draw this line. First I draw this line here. Okay, this is our line I have drawn. This is also the line of symmetry. It divides the curve into equal parts. So here you see the normal curve always describe the probability under this curve. The maximum value of probability is 1. So this line of symmetry divides the probability into equal parts, 0.5 on the right side and the 0.5 on the left sides. And this middle value or the centered tendency point is here we have. So the x bar would be here, and x bar plus 1 sigma, x bar plus 2 sigma, and x bar plus 3 sigma. Here also the x bar minus 1 sigma, x bar minus 2 sigma, and x bar minus 3 sigma. This point you look at here. Look at here, these points I have drawn here. Okay. So here on this point we have x bar. So x bar, first I would like to write down here whatever is given. So the given to us number one thing is given to us, n is 500. The total number of students is 500, and the mean weight, which is x bar, is 151 pound. It is 151 pounds, and the standard deviation is also given to us, which is 15 pounds. Okay, and we have given some other values. It is 120 and 155. So we could say that XA is 155 pound and XB is given to us 120 pound, and XC is also given us 185 pound. It is 185 pounds is given to us. These values have been given to us, and we see I put down these values here on this x scale first. So here you see x bar, which is 151, I will put down here 151. It is 151 point we have, and you see XA is 155, which is 4 point away from this, so we could write here. I change the color for writing down this point. It is 155 155. This point is 155. And here we see on the xb, this is our xa point, which is 155, and xb point we are taking here 120. So 120 would be here on the left side. So if we subtract this, we get how much we get here from 151. We subtract 120. So we subtract 120 from 151 minus 120. So we get here 31. So we know that the sigma is 15. We have sigma is 15. So it is twice of this sigma, more than the twice of this sigma. So it is x bar minus sigma, x bar minus 2 sigma. So it would be somewhere at this place. So we get here this value, which is 120. So I draw here some vertical lines. One line I draw here at 120. Okay, one line I draw here at 155. Okay, so first of all, in the first part, between 120 and 155 pound, the number of students having weight. So we have to find out the probability between 120 and 155. For this, we have to first find out the corresponding value on Z scale for 120 and for 155. For this mean value, always the value at Z scale is 0. So here we get 0. So now we have to find out the corresponding value of 155 and 120. So we find it out through this formula. So first of all, we say it is our xa. I write down here, this one is our xa. I choose one color here. This is our xa point, and this one is our xb point. So we have to find out the corresponding value za and zb. So we get here zb, and here we get za. So we have to find out this value za and zb, za and zb. We have to find out these values. Here first we find out za corresponding to xa. So which is x, we have 155, and x bar we have 151, and a standard deviation we know that it is 15 here. So we subtract this by 15. So it is 4 over 15, which is 0.2667, or we could say that it is equal to 0.27. So we could write here 0.27, 0.27. So this value is 0.27 at this point, corresponding value of 155 on Z scale. So now we have to find out another value, ZB. The same formula we are using here, x minus x bar over sigma. The same formula we are using here. The xb, we have 120, so we write down here 120, and the x bar would be 151 as it is, and the 15. So it is minus 31 over 15, which is minus 2.0667. So we could write this in this way, minus 2.07. So it is minus 2.07. We have got here value minus 2.07. So this is the value we have got here, corresponding to 120. So now we have to find out the area of region between minus 2.07 and 0.27 and this curve. First we get the probability PA, which is the probability between 0 and 0.27. So we see on the normal distribution table, here we see the 0.27, 0.2 and 7 at this place. This is 0.07 and 0.2, so 0.27 would be 0.1064. so this would be the value. So it is 0.1064. We have got this probability. And PB we have to find out. PB is the probability between 2.07 and 0. So we see the value at 2.07. Now we will find out the value of 2.07. So 2.0 and we see the 7, 2.07, 0.4808. So we get here 0.4808. .4808. So this is the value. Now we add these two values. The reason we add, why we will add it. So we are getting the value from here 0.4808, this value, and this value we have got 0.1064. So we add these two values, so we get the area of region between 120 and 155 here. So we find out this area, we adding this 4 and at 12, 1 carry, it is 7, it is 8, it is 5, so it is 0.5872. This is the area we have got. This is the probability, final probability, we have got this. Now we have to find out the frequency distribution. Frequency if we have to find out, then N into P. So N we have the 500 and P 0.5872. So I explain you, N is here, look at here, N is 500. So we calculate this, so it is equal to 293.6, or we could say if we round off this, so we get 294. So the first reply, our answer 1, it means the 294 students, 294 students having weight between 120 pound to 155 pound. So this is our first answer. We have got the number of students having weight between 120 pound to 155 pound. Now we see another question is there. Second part of the question, more than 185 pound. So I explain you first 185. So we have X bar is 151. So we see what is the difference between 151 and 185. So 185 minus 151. So you get here the difference of 34, which is X bar, it is more than X bar plus 2 sigma. So here you see the X bar plus 1 sigma and X bar plus 2 sigma. So we get somewhere here at this place, that point. So I change the color for this point. So this is our point XC, which we could say we have written it is XC. Third point XC, I explain it here. This is the XC, which is the 185 pound. So I write down here 185. 185. So I draw one line here again. So I draw one line here again. Now we have to find the area between 151 and 185 first, and then we subtract this area because we have to find the more than 185 points. We would be on the right side of this. It would be here at this place. We have to find out the probability of this place. I change the color. The probability of this place we have to find out. Right side of 185. So for this we have to find out the area between 151 and 185. Then we subtract this area from 0.5 because on the right side there is 0.5 probability. So we subtract this probability from 0.5, whatever we get here. Again we use this Z transformation formula. So we use that Z C is equal to XC, we have 185 and X bar is 151 and sigma is 15, we know that. So it is, again we have 34 over 15 here we are. So it is equal to 2.2667. We could write if we round up this, so we get here 2.27. So we are getting this 2.27 here on the right side. So look at here, the value of this corresponding Z value we are getting here. The corresponding value we are getting here 2.27. So at this place we are getting this value. Okay, 2.27 here at this place. So this we have got. Now we see the area under mean and this value, or the 0 and this value at the Z scale. So we see 2.27, 2.2 is here and 7 is here. So it is 0.4884. So the value is 0.4884. 0.4884. So you get here value probability 0.4884. This value we have got, but we have to find out the value beyond this region, beyond 185 or beyond 2.27. So we subtract this from 0.5. So we get here 0.5000 and 0.4884. So we get here 10 minus 4 is 6, 9 minus 8 is 1, 9 minus 8 is 1, and here 0. So we got here the probability which is 0.0116. So now we have to find out the frequency. Frequency is equal to n into p. So we get we know that the n is 500 students we have, and 0.0116 we have to multiply here. So you get here 5.8. So we get here 5.8. We make it round off. So it is 6 now. So we could write the answer in this way. Answer 2 we could write in this way. 6 students having weight more than 185 pounds. So in this way we could transform X scale into Z scale, and we could find out the frequency distribution of the X values. Thank you.